Okay, we'll get back to section 3.2 here. I guess the next thing to talk about is I have a worksheet here. It's called Quadratic Equations and Applications. There's some problems where you're completing the square, using the square root property, using the quadratic formula, and then there's some story problems after that. And so then the next thing, and all the answers are on that too, right here, you know. So I thought, why don't we just look at some story problems here. I selected some in the notes. So problem 13 is a good one to start with. So it says the product of two consecutive even integers is 168. Find the integers. All right. So we want to create a quadratic equation. By the way, all the equation setups here are going to be quadratics. If you don't have a quadratic, you probably don't have the right setup. Okay, so it's got to be in the form ax squared plus bx plus c equals 0. But I got to, you know, some even number, which I'm going to call x. Okay, consecutive means that they're right next to each other. Okay, like 2 and 4, or 8 and 10. Okay. The product means that if I multiply these two numbers together, I get 168. I'm supposed to find the integers. Okay, so x is some number. X plus 2 would be the next even number. Okay, and if I multiply these two numbers, I get 168. That'd be the setup equation that I need. And if we solve for x, distribute x, we got x squared plus 2x minus 168 equals 0. This quadratic equation will factor. Let's see, it's going to be x and x. The signs have to alternate plus minus because there's a negative at the end. And 14 and 12, 14 times 12 is 168. Now, what if we're not seeing that? We just can't do this problem? No. The next thing that we're thinking of is the quadratic formula. Okay? So there's always a way out. Okay? Think factoring first, and then if you can't see the factors, or if the equation doesn't factor, you know, then your next best option is to use the quadratic formula. So anyway, this one did factor. If we set each factor equal to 0, looks like x equals negative 14 and x equals 12. Okay, so if x is 12, x plus 2 would be 14. So if I take 12 times 14, I get 168. Also, if I take negative 14 times x plus 2 is negative 12. Negative 12 times negative 14 is also 168. Okay, both of these would be solutions to problem 13 there. Problem 16 is another one that I want us to look at. It says that a projectile is shot vertically upward from ground level with an initial velocity of 128 feet per second. Its height, s, in feet, after t seconds is given by s equals 128t minus 16t squared. Okay, part A says, when is the projectile 80 feet above the ground? Give the answers in the nearest hundredth of a second if there's any rounding, but there will be rounding here for this one. So in this one, t is the time, s is the height. Okay, I want to know when we are 80 feet above the ground. So if I set s to be 80, then I solve this equation. Let me get everything onto the left. 16t squared minus 128t plus 80 equals 0. Now I can make the numbers a little bit nicer. If I divide both sides by 16, I get t squared minus 16 times 8 is 128, and 16 times 5 is 80. By the way, look for those situations where you can make the equation easier than what it would be. You know, because I'll have people, you know, try to factor this, okay, and that's a mess. You know, there's lots of factors of 16, there's lots of factors of 80, okay? But now we're looking at something a lot easier than that, though, okay? Now, if I try to factor, the factors of 5 are only 1 and 5. The factors of 1 are only 1 and 1. No matter how I swing that, I'm not going to get a negative 8 in the middle. So the next best option is to use the quadratic formula. Okay, t is equal to the opposite of b is 8, plus or minus the square root of b squared, negative 8 squared is 64, minus 4 times a is 1, times c is 5, all over 2. Okay, and then when I simplify that, let's see, 64 minus 20 is 44. Now root 44 breaks down. I don't really care about that though, because I need to know the decimals that were that are solutions. Okay, so if I type this into the calculator, if I type in 8 plus the square root of 44 divided by 2, I get 7.32. Okay, and then I type in 8 minus the square root of 44 divided by 2, I get 0.68. Okay, so these both would be answers. So it looks like the projectile is going to reach 80 feet 2 times. Once on the way up, and it's going to continue to go up, and then again on the way back down. So once after 0.68 seconds have gone by, it's going to be at exactly 80 feet above the ground. And then it's going to keep going up, it's going to turn, and it's going to, head back to Earth. And after 7.32 seconds have gone by, it's going to cross the 80-foot marker again for the second time. So both of these would be answers. Okay, part B says, how long will it take for the projectile to return to the ground? Okay, so you're going to be on the ground when the height is 0. So if I solve this equation, 0 equals 128t minus 16t squared. Let's get everything on the left. And then here's my quadratic equation. The first thing is, I always think about factoring first. 16t is in common of these two terms, so if we factor that out, we got 16t times t minus 8. 16t equals 0 means that t equals 0. T minus 8 equals 0 means that t is 8. Okay, now the question, it says, how long will it take for the projectile to return to the ground? Okay, so at t equals 0, at time 0, we haven't launched the thing in the air yet. Okay, it looks like it's going to take 8 seconds for the object to return to the ground. Okay. Let's try problem 19 next. So in problem 19, it says the area of a rectangular garden is 105 square feet. If the length of the garden is 1 foot more than twice the width, find the dimensions of the garden. Okay. So if I draw a rectangle representing this rectangular garden, I'll call the width W and the length L. Okay, now I don't know the length. I also don't know the width, but they told me that the length of the garden is 1 foot more than twice the width. Okay, so whatever the width is, I'll double that, and then I'll add 1. Okay, the area of a rectangle is length times width. So if I multiply these two things, I got W times 2W plus 1. That is equal to 105 square feet. Okay, so this would be my setup equation that I would need to solve for. And if I distribute W and then get everything on to one side there, I got 2W squared plus W minus 105, that's all equal to 0. Okay, and that's my quadratic equation there. So, again, the first thing that I want to think of is, if this factors, this one will factor. The factors of 2 are 1 and 2, so it'll be 2W and W. And let's see, I know the signs have to alternate, plus minus, or minus plus, because it's a negative 105 at the end. 15 times 7 is 105. Okay, also, if I FOIL this back, I got negative 14w plus 15w, that's w in the middle. And then 15 times negative 7 is negative 105 at the end. Okay, so that's good. Again, if we are not seeing this, how it factors, use the quadratic formula. You'll still get the same answers. Okay, so anyway, this did factor, and so there it is. Okay, if I set the factors each equal to 0 next, and solve, 2w plus 15 equals 0 means that w is negative 15 halves. W minus 7 equals 0 means that w is 7. Okay, w is the width of this garden. That can't be a negative number. That doesn't make any sense for us. Okay, so I would throw away this negative 15 halves. That doesn't make any sense for the problem. It looks like the width of the garden is 7 feet, and then the length of the garden would be 2 times 7 is 14, plus 1 is 15. Okay, so the dimensions of the garden are 7 feet by 15 feet. And that's going to be the answer there. Okay, I got 3 more problems left in this worksheet here. So why don't we hit those in the next video? Okay.